darn it. So to check your work, you can do something like this. Add these up and then add those up. And the law of conservation of matter says that if you start with that many grams of something, they better be somewhere. They can't go away. I can't all of a sudden have 480 over here, can I? Where'd that come from? And I can't have 440. You can't have mass that disappear from the face of the earth. And so that's a real quick way to check. And you said, yay, I think I did these right. It came out like that. Now, the other thing I'd like you to do, even though you saw me do this, and then you saw me do this and this, eventually, I would like you to be able to do the whole problem with only one factor label with many chains. And I get that? So I could actually put this there, and once I get that in a calculator, write it there. Just write it right there. But then build this right next to it, and then write that number there. And then build that next to that, and then write that number there. So we actually should be able to do this in like one long step. You get that? And then use this as your map. Use this as where you put your numbers. You go like that. I'm not gonna penalize you if you want to do it in 3 separate steps like that. If you want to show your work like that, you can. But I think you're smart enough to say, if I were to do this and practice it, I probably could do the whole problem and just write the given. I write that down. I write that down. I write that down. I got the whole thing done. All right. Imagine you're taking a test, and I will show you a shortcut, by the way. But imagine you're taking a test, and all I want is the number of grams of that. Then you go, I need 1 step, 2 steps, 3 steps. So I'd have my given, and then 1 conversion factor, 2 conversion factors, and I'll be done right there. All right, so let's take a look at this. Even though I'm giving you a homework assignment on this, we're actually going to do quite a few of these in class. You get that? As a matter of fact, yesterday, if you watched the video, you don't have to watch the video because you were here, but I tried to show you how to do, and I think did we do all the first 4, didn't we? Did we do the first 4? Let's take a look at the first 4. All right. Now, it sounds strange. It doesn't look like a chemical reaction, but it says 10 large apples plus 2 crust plus 1 tablespoon of cinnamon yields 1 apple pie. And all they're trying to do is have you think about these numbers. See these coefficients? They want you to think about that. That ratio, those mole ratios, that's what tells you how to make a pie. Just like these that we had, it told you how to make carbon dioxide or water. All right, now, it says now that's the ideal situation if you want to make 1 apple pie. The question is, what if you want to make 25? So what happens is this 10-to-1 ratio has to be maintained. That number there should be 10 times bigger than that, shouldn't it? Well, then what if I start with 25? Well, then that should be what? Now, I can do it in my head, yes, but even if you didn't do it in your head, you could start with this you're given and say, I'm going to go sideways in the mole world, and where do I get my numbers? From the coefficients, and it comes out that way anyway. Are you okay with number 1? All right, look at number 2. Number 2, they're going to give you, it said they're going to give you 12 moles. They're going to give you this. All right. Now, watch this now. When you go sideways in the mole world, you look at the coefficients, don't you? So here's my given, and I want to convert 12 moles of that, and how many moles of this should I get? Well, look right here. See that number 2 and then number 3? Isn't that number bigger than this? Isn't it like 1.5, 3 halves times bigger? 3 halves, I get it. Coefficients make a ratio. See what I'm doing? And if I want to go from here to here, for every 2 moles of that, you'll get 3 moles of that, and that's how I get my final answer of 18 moles. Okay, we okay? I thought the hardest one was number 4. Let's take a look at number 4. That was the hardest one yesterday because here's my balance equation, right? And what did they give me? Didn't they give me this number right here? 2 times 10 to the 23rd molecule. Is that what they gave me? What do you think? Look at your question. Is that what they gave you? Look right here. What was the given? Wasn't that it? All right, now, So I put that there because I don't put anything below the equation unless it's moles, right? Only moles go below. So they want to know how many molecules here, and I asked Julia yesterday, I say, why don't we just go from here right to here? And said there's a tree in the way. So she understood that the plan is you have to go down, across, and back up. Are you with me now? So if you can say it in words, I know you can do the math. Molecules of O2, change it to moles of O2. Here we go. And where do I get these numbers? Where do these come from? Is that right here? Aren't those the equivalents, you know, the mole equivalents? All right, and that gives me that number. And then I'm going to go sideways in the mole world. Where do I get those numbers? Of course, May knows it's the coefficients. So I'm going to change for every 1 mole of O2, you get 2 moles of water. And that's how I go over to here. And then we have to go back up, and I got that numbers from equivalence there. I'm telling you, if you understand factor label and you know how to do equivalence and you know what a mole ratio is, there's no way I can stop you from doing these problems. Got that? All right. So let's try. What I'd like to do is I asked you to do 3 questions for homework last night, not to be turned in, but I want you to go sit with somebody for the next 5 minutes. Okay? So you have 5 minutes to go sit with somebody. And if you sit with somebody, neither one of you did them, go sit with somebody else. Say, sorry, you didn't do them, I can't sit with you. Go find somebody who did these 3 problems, or you can sit down and try them. Try one of them, 2 of them. All right, just take 5 minutes, go sit with somebody. I'll come around to your desk, and you said, I had trouble with this one, and I'll try to help you with that. good. I've been good. Okay, I'm good. Taylor, your work. Now, we're doing 3 tables. I highly recommend. I'm okay with this. Nothing wrong with it. But I highly recommend though that you split. I did before. Make these little road maps. And because in just a minute, we're going to. It's going to get more complicated. Like tomorrow, it's more complicated. So I have to have that little road map. And this is where the moles belong. This is where anything that's not moles goes up here. So there's nothing wrong with your word. This one, here's your balance equation, right? And I would have done the same thing. Just kind of get an idea in your head what I have to do. All right, now, my other thing is, I'd be really careful about that. How you do it? I wouldn't do it like that. I'm trying to help you. If you have a balance equation out there, you can kind of look at it, and you want to see what's going on with that. And on the test, I don't care what shortcut you use, but for a while, it helps show me how to do it. Okay. All right. Just everybody, stay where you're at right now. Stay where you're at. I want you to look up here, and I want to show you. I told you that one of my goals today, I wanted to make sure you could. You look like you're in pretty good shape on those. I'm going to ask you very nicely. I'm going to ask you nicely. If your problem doesn't look something like this, where you have the balanced equation and you have boxes at the bottom and maybe things on the top, that you're going to start doing that. All right, so let's go to number 6. Let's go to number 6, okay? 6. Let's go to 6. Now, you did 3 last night, so you'll have to go home and you can do 4 and 5 on your own. But I'm going to show you how to do number 6. Let's take a look at number 6. The good news is they gave me the balanced equation. And many times I will give you the balanced equation, but you're supposed to know how to do those anyway. All right, is everybody okay on that? Now, what I'm going to do is, you have to trust me. If I can show you how to organize a word problem, you're more likely to get it right. Okay? It's not a guessing game. We're going to organize this. So I'm going to read number 6. How many liters of carbon monoxide? Well, first of all, liters is not moles. So I'm going to put it up here. I put anything that's not moles, you're going to go up high. How many liters of carbon monoxide at STP are needed to react with 4.8 grams of oxygen gas? All right. Now, if you have a roadmap like this, I think I can do this problem. Now, what I'm going to do is, I want you to imagine the first step is I can't go from here to here. I have to go from here down to here, and then where? Everybody see what I'm doing? And then I can go back up. All right, so let's go ahead. What's the given? All right, let's go ahead and do that. That's your given. Now, again, I mentioned this before. If you can say it in words, you're probably going to get it right. Change grams of O2 into what? Moles. Excellent. All right, so then get rid of grams of O2 and change it to moles of O2. Unfortunately, I hate it, but the abbreviation for MOLE is MOL. Stupid. They only took off one letter, and there is no abbreviation for molecule, so you have to write it out. It's too bad. All right, so watch. Where do I get this? Where do I get this numbers? I'm certified, and so are you. I know that 1 mole of O2 is equal to 6.02 times 10 to the 23rd. Uh-oh. O2, what do I put after that? I think that's a non-metal and a non-metal forming a compound, isn't it? What do you call it? A non-metal and a non-metal forming a compound. Molecule of O2 equals, what's the molar mass? not 16. It's O2. Okay, now, everybody okay on that? Yes. Okay, why is it a molecule? Okay, because O2 means two oxygen atoms are bonded together to form a compound. A diatomic element is actually a compound, isn't it? And so it's a nonmetal and a nonmetal held together. And so that's a great question. Great question. Okay, now, and that's why I had to use 32, isn't it? Because it wasn't one O, there's actually two O's, aren't there? And that's why I used 32. Now, let's go over here. And we know that 1 mole of O2 is the same as 32 grams. Go ahead and put that in your calculator. And let's write that number here. Remember, never go below 3 sig figs. Do you have a calculator? Go ahead and get it out, okay? All right, everybody got it? So you're going to have 4.8 divided by 32, and Madison, what do you get? 0.15. One more time. 0.15. 0.15? What's the next number after the 5?
That's the only two numbers.
Okay, so I'm going to make sure that I'm going to put another number there just because it looks like 3 sig figs. Okay. Did everybody get that? All right, pretty easy. Pretty easy. Now, again, I know that some of you like to do it in choppy steps. I'm okay, but what I think I should do is just like this. I already know that this part gave me that number, right? Now, tell me what I'm going to do in words. What am I doing in words here? Aurora, you help me. I'm going to change what into what?
You're going from the moles of O2
Yes.
to the moles of CO.
What's that? What's CO?
Carbon dioxide.
Carbon what?
Dioxide.
What? Carbon dioxide would be 2 oxygens.
Oxide.
Monoxide. It's carbon monoxide, right? Okay, carbon monoxide. Now, here we go. We want to change, and you're right, moles of O2 into moles of carbon dioxide. So here we go. I have to get rid of that label there. Watch out. Get rid of moles of O2 and change it to moles of CO. And where do we get the numbers? Since I'm going sideways in the mole world, where do I get the numbers? Kyle, you know. Where do I get the numbers when I go sideways in the mole world? Yes. Okay, for this balanced equation, for every 1 mole of O2, for every 1 mole of O2, what do you have? You need 2 moles of that. Let's go ahead and put that in the calculator now. As a matter of fact, it's already in the calculator. You just have to multiply by 2, right? And did you get this? Did everybody get 3? Not 3. Did everybody get 0.3? Did everybody get 0.3? Okay, now, here we go. This is actually a neat little puzzle here. Now, what I want to change, who can I call on? Let's see, Sierra. What do I need? I need one more step. Change what into what? Of moles of carbon monoxide. Liters of, whoa, man, that's something new, isn't it? So watch, I'm going to show you how to do this, all right? Watch your hair. Let's do the mole concept for carbon monoxide. 1 mole carbon monoxide equals 6.02 times 10 to the 23rd. What am I going to do now? Help me out. What goes after Avogadro's number for this guy? Everybody in this room, every single one of you should know this. Non-metal compound, isn't it? Okay, molecule of CO equals, what's the molar mass? How much is it?
28.
Okay, 16 plus 12. Now, here's what's new. Ready? This thing called STP, STP simply means standard temperature and pressure. All right, let me tell you a funny thing about gases, okay? If I had a balloon and I said, how much space does that balloon take up? Well, if it's sitting in my room, it may take up this much space, right? What if I put it in a freezer? It'll take up this much space. What if I put it in a hot room? It'll take up this much space. See that? And so gases change their volumes greatly with temperature. How about pressure? What if I take this same balloon and I put it in a room that has 10 times the pressure right now as you feel? If I squeeze that balloon, it'll take up less space. What if I put it in a vacuum? And vacuum, the balloon will keep getting bigger and bigger and bigger until it maybe burst. So the only thing, this is not that difficult. Standard temperature pressure means that at 0 degrees Celsius and 1 atmosphere of pressure, and you say, what in the heck is that? If you go to the beach and you're at sea level, if you're at sea level, the amount of pressure that you feel in the air, which you don't even feel it, you just think it's air, that's called 1 atmosphere of pressure. If I were to go up to Denver, Colorado, 1 mile above sea level, it would not be 1 atmosphere of pressure. It'd be less, wouldn't it? You know that? Does everybody know that? As you go up in the mountain, as you go up in elevation, you don't have as much air pressure. Is that why your ears pop when you go up an elevator? When you're in a plane? So as you go higher and higher, you have less air pressure in your, and the pressure inside your ear is pushing out. It makes your ears hurt. That's why you got kind of clear your throat. So here's what we do. All you need to know is that when you hear STP, it simply means that scientists said, can we just agree on just some pressure and some temperature that everybody can say that's standard? Okay, that's all. And there it is right there. The people who came up with the mole concept, one person was named Gay-Lussac, and the other person's name was Avogadro. These two people, they did all their work with gases. And that's how they found out the mole concept. They said, if you had that much space, if you had any gas at that temperature, standard temperature pressure, then that's 1 mole. So if I fill that box with helium, everybody look at me, please. If I fill that box with helium, how much helium is in that box? It's 22.4 liters of space. What else is it? 1 mole. And how many grams of helium would be in there? 4. All right, now we'll fill it with O2. Let's fill it with O2. Now what's in that box? 1 mole of O2. How much space would it take up? 22.4 liters. How many grams of O2 would be in there? What is 1 mole of O2? How much? 32 grams. So now, all I want you to do, look at me, all I want you to do is add 1 more equivalent. That's all. And it's only for gases. It's only for gases. If you are a gas, you can say that 1 mole of any gas takes up 22.4 liters of volume. That's all I want you to do. That's simple. Got it? Now we go back up here, and you told me in words. You said in words, I want to change moles of carbon monoxide into liters. Here we go. 1 mole of carbon monoxide equals how many liters? So now I already have this in my calculator. So go ahead and put this in there now, times 22.4, and we can do it. All right, look at your neighbor and see what they got. See if your neighbor got the same one. Now, I don't have these answers memorized, so I don't know what the answer is, but did you guys all get the same answer?
Yes.
Did you get the same answer? What's your answer?
6.72.
Say it again.
6.72.
Ooh, I like this. Did you guys get 6.72? So what do you think? So, wow, that wasn't so bad. All I had to do is, for gases, I just have to know one more thing. And there it is right there, 22.4 liters. All right. Well, that's one of my goals. And now you should be able, on your homework, you should be able to do number 7 and number 8. Number 7 and 8 are just like we did. And you should be able to do that at home, okay? Now, one of my other goals today was to show you, and I almost hesitate to do this because I think you're just now getting used to showing your work. And I will make you show your work, okay? But I would like to show you a shortcut. Because when you take the test, you don't want to spend this long on a problem. How long does it take us to do that problem? It was over 5 minutes, wasn't it? Maybe 7? I can show you how to do this problem in 2 minutes. So I'm going to show you some shortcuts, okay? So what I'm going to do is, I think I'll start with, let's do number 5, okay? Let's do number 5, and I'm going to show you how to do the shortcut, okay? Calculate the mass of silver needed to react with chlorine to produce 84 grams of silver chloride. All right, let's go ahead. Write the balance equation and give me some space, okay, on top and the bottom of it. Wow, they didn't give you the balance equation here. Zach, what's going on? What's going on? Everybody's writing out number 5. Everybody's doing number 5. Did everybody put AG? Everybody know silver is AG? Okay, what's the next thing you need to know? What's chlorine? Uh-oh. Chlorine by itself? You can have as many chlorines as you want in a compound, but when it's just chlorine gas, it's diatomic, isn't it? Uh-oh. Gotta remember that. And what are you trying to produce? Silver chloride. Okay, on the periodic table, silver is an always metal. Remember, silver, zinc, aluminum. Silver is +1, zinc +2, aluminum is +3. And what's chlorine? Everybody, what's chlorine? -1, so I'm okay on that, right? Now, don't do stoichiometry unless you have a balanced equation. So we have to balance the equation. That's not so hard. Look, 2. There you go. All right. Everybody okay balancing equations? Yes? All right. All right, I want you to look at me because you got to promise me if I show you the shortcut, you will eventually learn how to use the shortcut to check your work. But you cannot tell me that you only want to do shortcut. I'll make you, like tomorrow, if I give a little pop quiz, I'll make you show me your work. You get that? If you want to go back and check it with the shortcut, you can. But I cannot teach chemistry by only shortcuts. All right, I'm going to show you a shortcut. Ready? What's the given? 84 grams of silver chloride. Okay, 84 grams. All right. Now remember, I put it up there because only my moles go below, right? Now I'm going to show you how to do the shortcut. I can do this entire problem. I can do this problem, and I can do everything on this problem. If I just do some molar masses, okay? Give me some molar masses. What's the molar mass of Ag? What's the molar mass of Cl2? And what's the molar mass of AgCl? If you give me those molar masses, I'll show you how to do a shortcut. All right, what's silver? Yeah, 107.89, 107.9 or 108. What do you want to use 108? I'll just do 108, okay? What is it for Cl2? 35.5 plus 35.5 is what? 71? Okay, now let's do silver chloride. It'd be 108 plus 35.5. 108 plus 35.5. Did you get 143.5? Did everybody have 143.5? Okay. All right, now, I'm willing to show you the shortcut, but all your work, all your homework, you have to show your work. Get that? No shortcut on that. All right, now, here we go. This is kind of fun. The shortcut's kind of fun. And, okay, thanks. So what I'm going to do is, does everybody have your calculator? I'm going to show you, I'll bet we can get this problem done in under 2 minutes, maybe under a minute. All right, I'm going to show you how the shortcut works, all right? What do they want me to find on number 5? It says here, calculate the mass of silver. So I go like this, and I say, I know that's what they want me to find. Yes? All right, are you ready? Are you ready for a shortcut? All right, here we go. Did you notice that every time we went down in the mole world, when you go down in the mole world, you always divided by the molar mass. That's my shortcut. All right, calculator's clear? Go. Put 84 in there. When you go down in the mole world, you divide by the molar mass. What's the molar mass of AgCl? All right, do it. 84 divided by 43.5. Everybody there? Is everybody there? Okay, and we don't, I'll go ahead and write the number here. But what number did you get here? 0.585, okay. You have to have at least 3 sig figs, and you did. All right, now, watch now. You're going to like this one. When you go this way, you have to look at coefficients, don't you? Watch. I'm going from here to there. Matchy, matchy. If that's 2 and that's 2, if that's 20, that's 20. If that's 0.585, what's this one? Oh. Isn't it right? Doesn't it have to match? Don't they have to match? And now, here we go. Let's go up. And when you go down in the mole world, you divide by molar mass. When you want to come up out of mole, you multiply by molar mass. So what's the molar mass of Ag? All right, take that number and multiply by 108, and what do you get? Does everybody see what I just did? When you go down the mole world, you divide by the molar mass. When you go up out of the mole world, you multiply by the molar mass of that. And I don't look at coefficients unless I'm going sideways. You get that? The molar mass of silver, 2 has nothing to do with it. Yes?
Can you explain why it's the same again?
Say it again.
Can you explain why it's the same on the bottom?
Okay. If you were to do the long cut where you showed your work, you'd say 2 moles of AgCl over 2 moles of Ag. And what's 2 over 2? What's anything times 1? It's the same number, isn't it? Here's what God said. For every 2 of those, you'll end up with 2 of those. I didn't do it. What if you start with 20 of those? You'll get 20 of those. What if you start with 4 of those? 4 of those. What if you start with 0.585 of these? See that ratio? The ratio has to be maintained. Now we'll do this one more time. We'll do a shortcut one more time, and I'm gonna tell me what this answer is. I don't know. Madison, what do you have? Let's say it a little bit louder. Sorry. 50. 63.2. Get at that was pretty fast, wasn't it? Can I show you? Even though this is not part of the homework, can I show you that if I had asked for this one, you could do that fast also? Now, stay with me. Here we go. Ready? Start here. Clear your calculator. Ready? When you go down the mole world, divide by the molar mass of AgCl. Do that now. 84 divided by 143.5. Everybody with me? Now, when I'm going to go over here, watch what happens here. Watch. This is a shortcut. I'm going from here to there. 2, 1, 2, 1. Gotta get smaller. Gotta get smaller. Here's your choice. Are you going to multiply by 1 over 2 or multiply by 2 over 1? Do you want 2 over, which one's going to make you smaller? Multiplying by 2 over 1 or 1 over 2? So multiply that times a half and you'll get that number there. Look again. 2, 1. Gotta get smaller. Which fraction will make you smaller? 2 over 1 or 1 over 2? 1 over 2. So tell me what you get here. It's going to be 0.293? 0.29 what? 3? Is that right? Now, ready? let's do that one. And you're going to go up out of the mole world. You multiply by the molar mass of that. So multiply by 71, you'll get that number right there. So what is that number?
20.8.
All right, now we're going to do a little check, okay? We did a shortcut. You say 41? No,
No, it's 20.8.
40.8.
No, 20.8.
Okay, 20.8. Now, can I show you something real quickly? Because you just learned shortcut, okay? How do we check to see if I didn't make a big old mistake? Add those up right there. Add up the grams of the reactants. What do you get there? Easy. Is this not, what's this number? Is this 63? Is that 63? Yeah. What's 63.2 plus 20.8? Is it 84 84? Is it 84? So right now, this adds up to 84. And what's this? Whoa! Oh! Okay. You think we did it right? Now, even though we have another part of this chapter, which is a little more difficult, if you can get this part of the chapter down and say, I think I get this, I think I'm going to be very good at this, then I can show you the last part of the chapter, and so that'll be it. So what do you think? I thought you made great progress today. I know you got here late, sorry, but you could actually go home and watch the video, and you'll see us doing those other problems we reviewed, and I think you'll be all right.